Now we have one last K-map rule. So as we said, every one must be circled at least once. Circles span a power of 2. Each circle must be as large as possible to make the implicant as small as possible. Circles may wrap around the edges, and a circle includes a don't care if it helps minimize the equation, but only if it helps. So we could have don't cares in our inputs and in our outputs. So first of all, why do don't cares happen in the outputs? Well, maybe that input combination will never happen, or we don't care what happens when it does. So for example, we may have a clock that is outputting 0s through 9s, but in order to encode that value, 0 through 9, we need a 4-bit value. So if we have a, we look at our watch on our arm, it's, it's showing us 0 through 9, but in order to encode that value, we need 4 bits. So the values 10 to 15 are not even used. So those outputs would be don't care because that input will never happen. And so here's a function with some don't care outputs. So that means we don't care if it's a 0 or 1. It has to be one of those, but we don't care what it is. And we enter this function exactly the same way that we enter our our regular K-map with just 1s and 0s. And so we're going to start with the top 1, 1, and then 0, and then 1. Remember, we skip a row to get this next one in, and then come back for our last one. And same for the rest of them, 0, X, skip a row, 1, 1. And now we get to our group here, and we're going to skip a column and go 1, 1, skip a row, don't care, don't care. And then finally our last group of 4 here, and those are all don't cares, but we'll enter it the same way for regularity. Don't care, skip a row, don't care, and then our final don't care. And so we've entered our K-map correctly, and now we're going to look for 1s, but we can include a don't care if it helps us make the circle bigger around a 1. So we're not going to circle don't cares just kind of, to include them. It's only if it helps us make a circle around a 1 bigger. And so let's look at a few of these. So we look at, for example, this one here. It has a 0 in that direction, so definitely can't go in that direction. But let's see, we could go to the right, and we could go to the left, and we could go down. So we can go 3 directions to circle this one. If we don't use the don't cares, we would circle just those 4. And so that implicant would be, it's a size 4 implicant. So it would have our 2 terms in it. This would be A bar and C. But we can use those don't cares to make the circle bigger. So that circle of 4 1s would be wrong because it's not a minimal implicant. But if we circle these don't cares here, now our implicant instead is just C, because the true and complement form, all possible combinations of A and B are included in that circle, and the true and complement form of D is included. So that implicant is now just C. Okay, and now let's look at some other ones here. We have these ones here. It's tempting just to go like that, but we can use don't cares to make that circle bigger. And so we are going to use those don't cares to make that circle even larger. So we're going to expand that circle to make it even bigger, right? If we had just circled those 1s, our implicant would have been A, B bar, C bar, right? A and B bar and C bar. D wouldn't have been included because true and complement form is covered in that circle. But instead of having that implicant that has 3 terms, if we use don't cares, now instead of having 3 terms in our implicant that covers those 1s, Now our implicant is just A. So we have the true form of A included in that circle. B has both forms included in the circle and all possible forms of C and D. So we only include A in our implicant. And now we look at this last one here, tempting to just do that, right? Or something weird, like, you know, definitely don't do that. Can't go diagonal. But remember that we can actually circle all of the corners. So all the corners have ones, so we can circle all of the corners here. And we get our B bar, so only the complement form of B is in that circle. Both forms of A are in the circle, so we don't include that. And both forms of C are in the circle. So we don't include C, but we do include D bar. And so we get B bar and D bar. Only the complement form of D is in that circle. And so by using don't cares, we expand our circles around our ones to be as large as possible. So by definition, because of the way I've implemented this circuit, any don't care that's inside of So by definition, any don't care that is included in a circle in my key map we're defining it to be a 1. Right? So the output will be 1 in the 1, 1, 0, 0 case, for example. We didn't care if it was a 1 or a 0, but by the way that I've defined my circuit, the output will be a 1 because it's included in a circle. But this don't care here, we've defined that to be a 0 because it's not included in one of the circles. And so we get our equation. This is again our implicant that is A. This one is C. So only the true form of C is included. All other forms of the variable of the variables A, B, and D are included. This is just A, and then we get B bar, D bar. So we have Y equals A or C or B bar, D bar. We OR those implicants then together.